Hi everyone, good morning or good afternoon, depending on where you are. I'm Robert Hawk, I'm Product Manager for Network Performance Monitor here at SolarWinds. I just wanted to thank everyone for taking the time to come out and meet with us and learn about what it is to have a large-scale SolarWinds installation. So I'm joined today with Leon Adato. He's a monitoring architect at Cardinal Health. So Leon was gracious enough to come out here and spend some time with us and tell us about his installation. Say hi to everyone.
Hi everyone.
So what we wanted to talk about was a large-scale SolarWinds installation. So Leon has a big installation. He's going to tell us all about it.
Excellent. Thank you very much. So the first thing that I want to talk about here when we talk about large-scale installations is, what are we talking about? Like, what's an enterprise? There's a lot of definitions out there as far as what makes up an enterprise, but they're all generally fiscal in nature, meaning, what's your net profit or your gross profits, how many locations do you have? And that has no bearing on a monitoring installation. So here's, in my not so humble opinion, what makes up an enterprise monitoring solution or an enterprise monitoring scenario. You could have over 2,000 devices. Anything over 2,000 tends to go beyond the small to medium-sized business and into the enterprise scale. Something more than 20 locations. And this is either or. It doesn't have to be all, but you have more than 20 locations, more than 10,000 elements. The old SolarWinds, it's an IP address, it's a disk, it's an interface. Those are the things that tend to tell me that I'm dealing with an enterprise more than a small or medium-sized business. However, at the end of the day, what we're talking about is when you need to add an additional polar, you might start to be thinking about an enterprise. And that has some very specific considerations in terms of what you build and how you build it and how you put it together. Now, just because SolarWinds can scale to the enterprise, why would you want to? Why would you want to try to shoehorn a tool that just may be part of the an environment where it's better fit for a medium-sized enterprise? Those 3 or 4 harried IT guys who have 300-400 servers they have to keep track of. Why would you want to take a solution like that and build it up? Well, first of all, because it can, and it can do it very well. But second of all, it comes down to cost savings. You've got the savings of cost in terms of implementation, and on the slide here you can see some reasons. We had at Cardinal previous installation, and this gives you an idea of what it took to get that into place. It took a lot of time. It took some consultancy. There was some questions about what done meant. And at the end of the day, we had about 6,000 devices monitored. Whereas with SolarWinds, we got it done much faster. We got it done without the consultancy. We got it done with a lot more devices. But go ahead.
I was going to ask, maybe now would be a good time to give a bit of background on Cardinal Health, the company, and just the size of the environment overall that you're dealing with there.
Sure thing. So Cardinal Health is a Fortune 20 organization. They have about 30,000 employees, and we've got about 10,000 devices, more or less evenly split between servers and network devices across the enterprise. What Cardinal Health does, stepping out of the monitoring stuff for a moment, Cardinal Health is in the healthcare sector. And they provide pharmaceuticals and medical solutions to hospitals and other organizations. So that's a little bit of background about what the organization is. The monitoring team, well, the monitoring team is relatively, comparative to the size of the organization, is relatively small. We've got about 7 guys who are in charge of handling most of the tools that we do for whatever it is that we're trying to do.
So all this is 24/7 knock and
24/7, follow the sun. We've got locations overseas. Yeah, all of that. So along with the ease of implementation and also simply what SolarWinds is able to do, really what your C-level executives, your CIO, is going to want to know is this slide. They're going to want to know that when you're talking about other tools, the enterprise tools, it doesn't matter which organization, but the ones that bill themselves as large enterprise class monitoring solutions, you're talking about typically the millions of dollars to purchase, millions of dollars in maintenance, your maintenance. An order of magnitude smaller in terms of purchase price, and then maintenance goes even lower, is where SolarWinds tends to be, and I will say is, in our specific case. As with any project that you are implementing in a large enterprise, if that's what you are doing, the failure does not typically occur in the technology section. It typically occurs higher up in the model. I've jokingly referred to the OSI model and the three, layers 8, 9, and 10. So that's not where things fail. Things don't fail at the technology level, they fail higher up. So I'm going to lay out some of the processes, some of the ideas that if you're trying to implement SolarWinds or anything really in a large enterprise, you're going to want to keep asking about and asking for. The first thing that you need to ask for initially when you're implementing SolarWinds and keep on asking for is you need to have a complete, accurate inventory. You've got to know what boxes you're going to get. Yes, SolarWinds does a network discovery. And yes, in medium-sized organizations, network discovery does great. But if you're talking about 10,000 devices, a network discovery across that size environment is possible, not advisable. You want to go on a model of, you tell me what you want to monitor and I will monitor that. Later on down the road, you will start to do mini discoveries to make sure that you found everything along the way. You just don't want to use the discovery as you're going in. And it doesn't matter whether it's SolarWinds or some other tool. It's just not a good way to go. The other thing you need to do is make sure that you've got connectivity at 2 levels. One, can you ping the sucker? I mean, just can you get to it? And although that sounds stupid, in large organizations, there's a lot of, oh, yeah, I forgot that our core can't directly get to the device that's out in, Kuala Lumpur or Sao Paulo or whatever. You need to make sure that your polling engines are permitted and able network-wise to get to those boxes, and not just at the ping level, but also all the ports, and we will talk about them, but all the ports are able to get to those devices as well. This is a major hang-up in a lot of enterprise installations, is that they tell you can get there, and then when you start to try to get there, they realize that, oh, we need this firewall request and that firewall request. It slows things down. The other thing related to that is that you have an account, a Windows account, whether it's a local account on every server, we're talking Windows servers, or a domain account. Same thing goes for Linux and Unix, that you've got an account that is able to do the scripted or the counter type polls that you're going to need to do. Finally, SolarWinds is very much an SNMP oriented tool set, so you need to make sure that SNMP is turned on the boxes and that you know what the read-only string is going to be. Finally, a discovery of mine is that some organizations don't permit, that the devices don't permit SNMP polling. What am I talking about? There's actually in Windows a box that says the permitted pollers, that's that bottom half of the screen. The permitted pollers are only this server, that server. I was at a client where I actually had to ask for all 10 of my polling engines to be added to the permitted pollers list, which required a GPO push, which required a 3-month lead time. So there's all sorts of gotchas like that. It still comes back to the previous slide I was talking about, which is you should ask for this stuff immediately when you start and keep on asking for it until you know you've gotten it. There's 4 other questions that I like to ask if you can build it into your rollout project that really make the difference between a we just slashed and burned and got it out there implementation and a monitoring implementation that proves its own value. First of all, when people are asking for alerts, ask them, what are you going to do when you get this alert? The answer I get back often is, well, nothing, I just like to know. Sorry, I don't get paid by the bushel for alerts. If you don't have an actionable response, we're not going to build an alert for you. That's called a report. SolarWinds does those, but a lot of organizations really do reporting by inbox, how many alerts they get. Do you have a documented procedure, meaning at 2 o'clock in the morning, does the ops guy or the NOC guy know what to do? No, that may be the point to push back and say, look, I got to have a documented procedure because in my alert, I'm going to link to the knowledge base. That would be great. And the ops team will love you for it. Can you make this problem happen on purpose? When you're testing, the number of times that I get asked for an alert and it says, well, when this such and such happens or when this message appears in the log or whatever, oh good, can we try that one so we can see? And all of a sudden the alert message doesn't look anything like what they said, or they say they can't do it. Now that's one of those you have some wiggle room. I set up an alert for high temperature in the data center, and I wasn't about to tell the data center manager, by the way, go light something on fire now and let's see what happens. No, you don't have to do it every time, but it's a good question to ask. And finally, what will happen if you don't get this alert? Well, 3 guys are going to have to spend 2 hours investigating. What you just got is your value statement. You can take that information that this problem would escalate to a system down that would take half an hour and 3 people. You can turn that around into every time you cut the alert, this is how much money you saved the company. And your manager, and typically the CIO, is going to love going back to the organization saying, this month, this is how much money we helped you avoid spending. So let's get to design. Here's a basic design that we're talking about, and it's pretty straightforward. It's not much far off from what a smaller implementation looks like, just a couple of variations. First of all, in the center here, you've got the primary polar. That's, the first installation that you do with SolarWinds, the first polar you build. And then you've got the additional polars. They can be in the same location with each other. They don't have to be. We'll talk a little bit more about that later. However, higher up on that slide, the database server really needs to be co-located with the primary polar. You want those guys right next to each other network-wise so that there's no lag time between the two. Over on the right side, in the pink box, the core or even remote sites, as long as they're on the same network, you're just going to be passing ping, perfmon counters, WMI, SNMP, all that stuff is going to be moving back and forth from the polars, both the primary and the additional, and they're just going to be talking back and forth. Meanwhile, down below in the DMZ, you're coming through a firewall. You're probably going to want to put an additional polling engine in the DMZ to handle those DMZ boxes. Yes, it's going to be a relatively expensive box that's going to probably handle a relatively small number of devices out in that DMZ area, but you want it both for your security and also for the ease of implementation. And when we talk about ports, you'll understand why. Finally, if you're in an enterprise, you want to offload the responsibility of web display by adding an additional web server on the front end of the primary polar. The primary polar and the web server talk back and forth to each other, and that way your users are connecting to the additional web server. What that also lets you do is if you want to create a public URL, one that does not require someone to be in the Office network, you can do that. You can use HTTPS and put that outside the DMZ from the user perspective so that at 2 o'clock in the morning, someone who gets woken up by their phone can punch in a URL and get straight to the web display without putting them right on the primary polar.
Now for folks that may not be familiar with additional polars or additional web servers, that may sound kind of scary. So you're sitting here looking at this topology diagram and going, well, that looks great and makes sense to me conceptually, but I'm used to some of the big four that just setting up anything additional outside of the first installer gets kind of hairy. Maybe you can tell us how how that installation process looks.
So I did that just a few months ago. I installed for Cardinal Health. We started off with 6 polars, 1 primary, and 5 additional polars plus an additional web server. The installation for all of those, all 7 boxes, took me 4 hours to build the boxes. The load of my initial devices, I had an inventory of devices. It was about 5,000 servers. That took me an additional, I'll be conservative, 6 hours. So a 10-hour day, and I was off to the races and running. Now, granted, I had done my homework ahead of time. I knew what I was building, the servers themselves, the metal, the OS, and the IP addresses and everything. Those were already set up. It was really just drop the installations down from the SolarWinds customer portal website, drop them onto the boxes, run the installer, off you go. Same thing. Another element that I should mention is, in terms of installation, is that the database server was set up, and I had an account that had SQL admin privileges to build the account. So I had all my accounts, those ducks in a row. So when I started installing, there was no scrambling for, oh my gosh, I can't install this, I got stopped, or whatever. You want, if you're planning on an enterprise solution, you're going to want to do a dry run once or twice. And that's fine. The 30-day evals will let you do that stuff. Just do a quick install. You're probably talking about 3 hours of your time on an afternoon. And run the install, find out all the gotchas, and then when you're ready to do the real one, you know what it is that you need. So there's a couple of additional elements that I like to add on in a true enterprise that help keep the SolarWinds installation running well. So this slide lays that out. It's the same slide as you saw before with a couple of additions. The first one over on the right is the syslog and trap. I build a cluster of servers. 1, 2, it depends. Just depends on the environment. Because I always expect all syslog and all trap to be coming to me. In the past, when I tried to do that straight to the SolarWinds polling engines, that volume of traffic, syslog is incredibly chatty, traps are only a little bit less so, that volume of syslog and trap traffic, most of which is noise, can be ignored, overwhelm the polars. So I create a cluster of other servers. Now there's a lot of other tools. If I was going to be a SolarWinds fanboy, I'd mention Kiwi Syslog. Not a bad way to go. But there's also freeware versions. You can go with a Linux-based solution that uses open source. You want something, though, that is taking that initial line of syslog and trap and filtering out all the noise and only forwarding, and it's forwarding, it's actually invisibly forwarding the original IP address and the original message into the SolarWinds implementation. It will match up the IP address that the syslog trap cluster sees to the IP address of the device that you're already monitoring in SolarWinds, and it will do that correlation. But what you've done is you've filtered out 90% of the messages you're going to see so that your SolarWinds implementation isn't wasting cycles just throwing things in the bit bucket. The other addition that I'm showing on this slide is in the upper left corner, which is the recognition that you're going to have some kind of event correlation engine, and you're going to have some kind of ticketing system that SolarWinds is going to need to talk to in some way. How you do it really depends on the tools that you choose to use, and that's beyond the scope of this particular talk, but I did want to mention that those are considerations in your design. So let's talk about ports, and I do have to, tip of the hat to Alter Ego on Thwack for the wonderfully named Portocalypse. I can't even say it. The Portocalypse post, which is on Thwack. So what do you need? Well, for SNMP and RPC, if you're going to do that, you're not going to do WMI. Just hold that thought for a second. If you're going to do SNMP and RPC and ping, you're going to need ICMP bidirectionally. This is what you're going to tell your firewall guys. This is what you tell your network guys. You need to have ICMP bidirectional from your polling engines to whatever targets you're going to be monitoring. You need all those TCP and UDP ports. Okay? If you have those, RPC monitoring, we'll talk more about what that means in a minute, that will work. This is also why in a DMZ environment you probably won't get it. But the real reason why you're not going to get it is that last bullet point at the bottom. If you want WMI, you pretty much are going to need any port over 1024 because WMI uses what's called ephemeral ports. It'll pick something over 1024, and oh, by the way, it switches mid-conversation. So it's not even like, as long as it opens on a port, you're going to have that port. It flips up and down all the way through. So you just need all of them. Or Alter Ego has laid out a way to modify your Windows servers so that they lock themselves to a single port or a range of ports. Again, that's beyond the scope of this particular talk, but the Thwack post does a good job of going into it. If you have a DMZ, you're still going to need some stuff. Now remember, you're going to have an additional polar in the DMZ. You will still need all the ports I mentioned in the previous slide. Those are still going to need to be open from the DMZ polar in that blue box to all the targets in the DMZ. However, the additional polar will need to talk back to your core on just a couple of ports. You will still need ping bidirectionally, and you'll have to make sure that your DNS resolves, even if you're coming from one Active Directory domain to another Active Directory domain. They've got to be able to work both ways. You're going to need to have TCP 1777, 1778. You will need port 80 or whatever your SolarWinds web server is running on. If you install the web server on 8787, that's what you'll need, because the additional polar is going to need briefly to talk to the web server running on your primary polar. And finally, the additional polar will need to talk to the database. So it's going to need to talk on 1433, whatever port your database is being set up on. And by the way, for people who have SQL teams that don't like ports and like named instances, they won't work. They will need to add, not change, but add a port for this polar, or else it's not going to install. So just FYI. But you don't need, and your firewall team, if you show them that previous list, is going to freak out. You can tell the firewall team that for DMZs, your additional polar only needs a couple of ports, and then you're good to go. This helps to relieve their stress a little bit. It also makes the justification for why an additional polar is a good idea in your DMZs.
Yep, and those additional polars in the DMZs would only be talking to, the couple individual boxes that are sitting, behind the firewall. So
Correct.
Just direct to the single database server, just direct to your main polar. So, a couple ports limited in scope in terms of destination to 2 servers, let's say.
Exactly. And the nice part about the additional polars is that they are configured so that everything between the additional polar and the DMZ and the core is encrypted, including the connect string to the database. Even that's encrypted. That's one of the things my SQL guys insisted on, was that there couldn't be any passing of passwords and things like that. Obviously, that's a security flaw, and luckily that's not an issue either. So let's talk about account permissions. To do RPC collection, you need just a little bit. It's actually not that much. The RPC account has to be a member of you can see the sub-bullets there. I'm not going to read the slide to you, but it has to be a few things. However, WMI gives you some stuff that RPC just ain't going to do. And the one compelling phrase I can give you is virtual mount points. You really want WMI in any kind of modern environment, certainly any kind of enterprise environment. You're going to have those. So you want to go there. To do that, you need a little bit more. You need to be a member of Performance Monitor User Group. You need to be a member of the Distributed COM Users Group. You have to have remote desktop, allow login locally. You have to have the root added to the SIM v2. There's a whole ThwackCamp article on this. The upshot of this statement is give it local admin. Really, you just got to give it local admin.
I think your security guy just shuddered a little
Oh,
bit.
absolutely. He just had an aneurysm. But we tried to go the other way, and when we talked about what it would take to roll it out across our 4,000 Windows servers, the justification just fell apart. So, it's the good news is, again, you're still talking about Windows security. I realize that those two words sometimes end up being oxymorons, but you do have a security model around this, and you are talking about pulling performance counters. So, the scope of exposure is relatively limited. I do want to mention this screen doesn't talk at all about Linux or Unix. The Unix account just needs to be able to SSH to the target, and it needs to be able to execute typically scripted commands via SSH directly. And the reason why I say that is that in some environments, users can log in with one account, but in order to execute any sort of elevated command, they have to sudo into another account. SolarWinds isn't going to do that. It needs to be able to log in through this service account, and it needs to be able to execute those commands immediately with that service account. However, Linux has a feature that Windows doesn't, which is that you can actually tell in the sudoers list which commands that account is permitted to do, so you can lock it down in a very granular way. You can tell your Linux admins or your Unix admins, hey, this account needs to be able to log on locally with SSH, it needs to be able to run these commands, but these are the commands I need. And then they can know that you're not going to go off and create new users or, start running Halo or whatever. Okay, so I told you what you need for WMI stuff, and you can't. Now, there's two scenarios where this is going to occur. One, the security team has keyed your car and put salt in your gas tank, and they're telling you that you're never allowed in the building again. The other one is that you are trying to monitor across a natted VPN. And this is actually more common than you might think. A lot of organizations have some sites that are directly on the network, but some sites that have simply a nailed VPN where all the devices are natted. WMI doesn't work across that. It's not a limitation of SolarWinds. It's a limitation of WMI. Simply can't do it. For that reason, you need to be aware of what you're giving up. Now, most of the SAM activities that by default use WMI can be leveraged to use RPC. You can get processes and services using SNMP. It will give you CPU and RAM. What it won't do is it won't let you restart the service if you go that way. Windows event log messages can be gathered through RPC. Windows processes and services, as I mentioned before, can also be monitored through RPC. Perfmon has always used RPC, so you can do that. However, what you're giving up, A, virtual mount points. Really, if there was no other compelling reason to get WMI working, that's got to be it. Restarting a service as an alert action. Real-time processes and services will not work unless you're monitoring that service or process through WMI, not through RPC. And then there's certain other things, Windows script monitoring and W monitors. W monitors are like a duh, but Windows script monitoring requires that VB script is allowed to work, which typically are very similar in terms of what you need. So you have to be aware of what you're giving up, or you have to use this information to make your case about why you need it to be working. So let's build some servers. Okay, let's talk about the database server first. How much CPU do you have? Send it in. You want as many CPUs and as much RAM as you can. I'll be honest, the server that I'm using has 12 CPUs, real, physical. This is an actual server, not a virtual. Has 12 CPUs, 128 gig of RAM. Also, in terms of disk, you want RAID 10, not 5. Or in my case, the SAN team said, don't ask me what we're doing for RAID. We could load your entire database into memory and have it run from there. Okay, I'm all right with that. You just need to make sure that if you don't have a SAN team that tells you that, you need lots and lots of spindles. That's what it comes down to. SolarWinds does a lot of reads and writes, little bitty reads and writes, and so you want to have as many spindles involved as possible. The pollers can all be virtual. Your primary can be virtual. Your additional pollers can be virtual. Your additional web server can certainly be virtual, and it does not need to be as beefy as the database server. I tend, in most of the installations that I do, to have about 8 CPUs. Again, these are virtualized. What you will 8 CPUs and 12 gig of RAM. One note: the speed of those CPUs, the core on the ESX box, makes a difference. There is an enormous processing difference between a 2.8 gig core and a 3 or a 3.1 or even a 2.9 gig core. I've seen situations where 4 CPU 3.1 gig is fine, but 8 or even 12 CPU with those slower cores doesn't keep up as well. It's not a matter of throwing CPU at it all the time. So just be aware of that. And memory, I've always found, especially since version 10.3, where the polling gets throttled automatically, I found that the RAM is typically very happy. As I mentioned, disk is a big deal for your database. Everything has to be in the same time zone, even if it's not. This is a pet peeve of mine, and I'm sort of poking Rob here as I talk about it. But the reason is that if you have some of your servers that are in, let's say, Central Time, and some of your, polling engines, if some of your polling engines are in, meaning they're set to Central Time, and some of your polling engines are set to Eastern Time, you're going to look at one server, and it's going to say the event happened at 11 o'clock, and one server is going to say the event happened at 10 o'clock. It also means that at daylight savings time, you're going to have a really interesting problem when some devices suddenly lose an hour, or all of them lose an hour. So you have to be aware of that. I'll talk a little bit more about that later on. But all the polling engines, all your devices, and your database server have to all be set to the same time zone, even if they're not physically in the same time zone.
Yeah, we do store most of the data in UTC. However, there are some legacy data points that do respect the local time zone. So it's definitely something we're aware of, and we'll get it tuned up.
Excellent. That was my little commercial. Wonderful. And as I mentioned before, the primary poller and the database must be in the same location. There's just so much conversation going on between those two that they have to be very, very close so that the network latency is kept to a minimum. But the question that everyone asks when they're talking about an enterprise is, how many pollers am I going to need? I'll cut to the chase. There is no formula. We all know that SolarWinds says you have about 8,000 elements per poller. They lie. I'm saying that right here. I'm in SolarWinds offices. You can really push it to 10,000 as long as you give your polling engines enough beef. You can get 10,000. You can get over 10,000. But what are we really adding up? What are we talking about? Well, certainly we're talking about the SolarWinds traditional element, which is a pingable IP, an interface, or a disk. But you also got these universal device pollers. And if I roll out 5 or 6 to all 4,000 of my servers, that's got to have an impact somewhere, right? It doesn't count against my element count. It doesn't count into licensing. I don't think anybody from licensing is in the room, right? I haven't given it away. Okay, so, it doesn't count licensing, but it does account for load. SAM components. You go out and you buy an unlimited license of SAM. Yay! But it's still going to have an effect on your polling engines if you're doing that all the time. Finally, something that you do need to be aware of is how many down items. A down element is going to require more of the polling engine to validate and to find out what's going on an ongoing basis than something that's up. So you have to know. Like I said, there is no formula. You got to watch the environment. I do know, I've been told in the past that the ultimate limit is about 110,000 elements per SolarWinds instance. At that point, you can go higher, but you have to start to use the enterprise, the enterprise event console, which will allow you to merge 2 installations together into one single pane of glass.
And to that point, that really is just a limitation of the database server itself. I mean, if you did bring to the table some cold fusion SSD powered database server, potentially you can push that as far as that hardware will allow. But I/O on the database server does tend to be the limiting factor in that discussion.
There you go. And the other thing I will mention is that you can ratchet that up by tuning your polling cycles down. You know, the default is to pull, to ping every 2 minutes, to pull S&MP data every 10 minutes, give or take. There's a little bit of leeway there. Okay, great. If you ratchet that down to ping every half hour and pull, S&MP information every day, oh, sure, you can bounce this up to 900,000. You can go as high as you want. But realistically, when you're talking about a real monitoring environment that you want the data in some kind of realistic way, you've got to keep an eye on it. That's why here's a report. It's available on Thwack that I've put together that tells me all of my pollers and some information that I want to know. Yeah, I want to know how long they've been up. Notice that a couple of boxes have been up for a little bit longer than I like. I like to bounce the SolarWinds boxes at least once every 2 weeks. If you ask me, and I'm a Linux guy, I would say bounce it every week. Yes, I know there are Windows server guys out there right now who are screaming at the screen saying, "No, they can run forever. They're fine. Just tune them." Yes, but SolarWinds is a .NET application. It does have, the need to have memory refreshed occasionally. A reboot is extremely helpful. Okay. And I say that as a guy who, like I said, I'm a Linux guy. I've been using Windows since it came for free on 12 5.25-inch floppies when you bought a copy of Excel. So I do understand how Windows runs. You want to reboot it. You want to know how long it's been running. Total elements, straightforward. This is how many I've got. The number of nodes, interfaces, volumes. Again, that's the traditional count up to elements. But I also show here how many UNDP monitors I've got, how many SAM components I've got, and how many of them are down right now. You'll notice that one of my additional pollers there in the middle has 1,053 SAM components that are down. I might want to look into that. That's an issue. Another one of my pollers has 439 disks that are currently down. That may be something to look into. The polling completion rate is over there on the side. It's actually an old number. I'm not sure how relevant it is anymore because SolarWinds throttles its polling, but it's available in the polling engines database, so I display it as a gotcha. If I see that number is at 80, it gives me an idea that I want to start looking into it. Same thing for how much CPU, how much RAM, the NPM polling rate, and the SAM polling rate. Those are all things I want to just know and be aware of, if for no other reason that when I'm adding another 100 boxes, I want to know which of those boxes I should be adding to, which one is the least utilized. So you've built your environment. You've got everything tuned up. You've loaded up all 900 billion of your devices and everything's great. You've gotten a bonus. They've given you stock options. You're a hero walking through the hallways. That's great. Here are the things that are going to kill you 3 months after you install SolarWinds. If you don't have these processes nailed down in the sense that you know how to handle them, you won't die on day one. You will die later from 1,000 little itty-bitty cuts. You've got to have a process to handle the life cycle of devices. Who, where, how you can add devices. Are you having your NOC add devices for you? Are you going to do network discovery to find your new devices? Is this a request in change control? Is it a ticket? How are they getting in? Along with the devices themselves, if you have additional information components, custom properties, where are they coming from? How are you getting them? When you add a router, who decides which of those interfaces are going to get monitored, which ones aren't? Are you just going to automatically? You've got to know how. There's no wrong answer here, but you've got to understand how they're happening. Same thing for disks. Same thing for SAM templates. There's all sorts of ways through the Orion SDK that you can operationalize that, but you've got to understand the people process first before you can turn that into a script. You've got to know how devices get decommissioned. You've got to know how devices get removed. If those two things aren't the same thing, you've got to know who and how you're going to handle down devices. Not just down devices, but devices that are pingable, but S&MP isn't collecting. How are you going to find it? How are you going to fix it? Applications that are in unknown status. I've seen in the past where that number will spike from a typical 200, 300, all the way up to 2,000. Okay, something's going on here, guys. Who's going to investigate? Duplicate nodes will happen. It's actually a feature in SolarWinds, not a bug. The idea is that when you have multiple pollers, let's say that you've got one poller in Cleveland, one poller in LA, and one poller in Sao Paulo, and you've got your 10 really, really important servers, you can monitor that server from 3 different locations and triangulate so that you know whether the server is really up or not really up. So they allow you to monitor from 3 different locations, but in most cases, if you find a duplicate, meaning same name twice, same IP address twice, That's a problem. You have to catch it and fix it, otherwise you're going to end up with a lot of mess later. Same thing for bad applications. You know, when applications stop working because somebody changed an account password or somebody applied the wrong template to the wrong box, you've got to be able to catch those and fix them. Those are things that have nothing to do with my environment is down. They have everything to do with I need to keep the monitoring tool clean. So here's some screens. Here's an example of a device outage display. There's actually been a lot of activity on Thwack the last 4 or 5 weeks about this. I want to know when blah blah is down, and I want to know how long it's been down. So there's plenty of report examples that will show you the number of days, hours, minutes. You can see I've got some devices that have been down for a long time. So you want to be able to catch that. This is your list of things to work on that you might give to the ops or the network team. Same thing here, bad applications, like what's going on? Well, I've got a few of these application templates that are giving an error, unable to connect, application is wrong, etc., etc. Some documentation that would be also handy to have so that you can take a vacation, win the lottery, walk away from your desk for 5 minutes, whatever. You want a run book that gives the overall design. I know it's a pain. I know. I know that nobody has time to document, but if you have this, you can hand it both upward to your management, downward to people that you're trying to train up to help you out. You'll want to have the overall design. You want to have a list of the accounts that are used for the installation of SolarWinds, because I will tell you, every time that I do a patch or an upgrade, it pops up the screen for the database that says, how are you connected to the database? Yes, it gives the one that it had before. But if you forget, or you have that oh no moment, or you sneeze and slam your head on the keyboard and type Gefrinkle by accident, you want some document that tells you what the name of the SQL account is and what the password is. You want to know what additional software you've installed anywhere in your environment. I like to install Perl on the polling engine so that I can do Perl actions locally if I need to, Image Magic to do some image manipulation, etc. You want to know what you've installed so that, God forbid, something dies, you can rebuild it fast. You want to document how Windows patches, I'm not talking SolarWinds patches, Windows patches. You want to talk to your patch team and say, when you install a Windows patch on my Polar, this is what needs to happen next. Same thing for SolarWinds patches. Just walk through the process. You want to document common troubleshooting, how to bring a Polar down, how to bring a Polar back up, how to validate that everything is healthy. You want all that. Also, really, this is a good one to have on hand so that people at 2 o'clock in the morning can do this for you. How to open a ticket with SolarWinds. They only need the account ID, not the password to the customer portal, but you want whoever is on call overnight to be able to open the ticket and get the process running before they call you and you stagger out of bed. Finally, there is a point at which SolarWinds currently falls short. Now, I will tell you that SolarWinds has done really an amazing job of beefing up their products in the last 2 years. They've really added a lot of features, and I expect a lot more features to come. But there are certain things you have to understand where SolarWinds doesn't fit in right now, or where it doesn't fit into your organization. One of those areas is event correlation. Yes, you have parent-child. Yeah, you can do some with the alert rules, but you may find that event correlation isn't as powerful or strong as you need. You need to look into whether you need another solution or not right now. I know that they've got big plans on that. You also have to understand where scalability ends. If you've really got 1 million devices, how are you going to handle that? You have to be aware of that. One of the things I see all the time, you don't have a DBA? Get one. SolarWinds is like every other product walking the planet. It doesn't just install and maintain itself. The SolarWinds team has done a good job of building in some maintenance scripts, but you need a real live actual DBA, not just somebody who's a DBA wannabe who can write a script, a query here or there. Somebody who understands when a database is happy, when it's not, how to tune it, how to tweak it, how to fix it when things happen. You're going to have one of those kinds of guys available. Don't let your management tell you that, oh, it'll be okay. It's not going to be okay. As I mentioned before, time zone. Polars have to all be in the same time zone, but also currently, and again, you heard Rob say that they're addressing it, right now twice a year, if you have any time-sensitive alerts, meaning if polling hasn't occurred in the last 20 minutes, every one of those alerts is going to fire once a year when you jump ahead 1 hour, and your last poll time is now an hour behind. Everything is now more than 20 minutes late. You're going to cut tickets. You have to be aware of those things for right now. Those are the, that's just a gotcha that I want to throw out there. But that's all I got. I mean, that's a relatively short list of gotchas for a product that can easily scale to hundreds of thousands of devices if you needed to. It's been really a pleasure talking to you. At this point, we're going to have some live Q&A, so I'm looking forward to your questions.
Yeah, thanks so much, Leon. Thanks for taking the time, and fire away with the questions, guys.
Thanks a lot.